Hi and welcome to today's webinar. My name is Bengt Are Zakariasen. I'm the Business Development Manager here at Flumroy, Norway. And today we are going to conduct some testing. I will start today by explaining it here. It's a very simple way just to explain how the Firebreather works. And after that, we will go out and we will do some bigger testing and also show how we do a flame arrest test standard, instant flame block, and also a system test. Okay, let's go out and have a look. So here we see the ASTM E2912 test. It's a big table. You will see some flames coming up from this area. And then we have the application lying on the table here. And Ole, our CTO, will join us when this test starts to explain the application. And after that, we will end it with our system test. It's a simple one, but it just illustrates how our fire will work in a more real-life scenario. So the application here is quite simple. We have the intumescent strip, which will be a conventional way to fire a safe cavity. And on the other side, we have the Firebreather Cavity Barrier. And it will show that no fire will go up in that side of the wall. Yes, I think we'll go inside again and start explaining about the Firebreather, how it works. It's quite cold today, so hopefully all technical equipment will work. But let's move inside and have a look. I will light it up like this. The Firebreather technology is combination of intumescent, which is an expandable material, alongside a steel mesh. In our case, it's a stainless steel mesh. And with the right gasket size, you will get instant flame block. For some of you who are newly involved in fire, you might see that this is very similar to the David lamp effect. And it is. So I will demonstrate it now. Here we have the cavity barrier with some drywall gypsum. And we will put it down in the splitter and see what happens. And now you see it stops. The flame doesn't go through. And I can even put my hand on top here to feel it. It cools that quick. You will see some smoke now. This is actually cold smoke because of the intumescent is expanding. This you will see on all expanding intumescent. It will always be some cold smoke there. After the intumescent is fully expand, the smoke will also go away. Yes, I will put on some welding gloves because it might get hot underneath it. Let it burn a couple of more seconds just to show you what happens when the intumescent has expanded. Okay, I think we'll try to lift it up. It looks something like this. And now you can see the intumescent has expanded. And then you get a full barrier. So the technology bases on stainless steel mesh with intumescent, expandable intumescent. And with that combination, and make sure that all the air goes through all of our valves, we'll get always instant flame block. I will try to put this out now. I'm standing next to our test furnace. And Ole are joining us now. He's our CTO here. Ole, what do you use this test furnace for?
So this test furnace is basically a small-scale version of a large fire resistance furnace. Normal fire resistance furnaces are anything from 4 by 3 meters to 1.5 by 1.5 meter in size. And they need to follow a very particular heating curve. So the temperature inside of the furnace needs to develop at an exact curve per time, and it needs to build a certain amount of pressure inside. Those are the two criteria that are needed in order to claim compliance with EN 1363 Part 1. So this furnace actually reproduces that curve. We can see here from a test that was done quite recently, there are two curves and they overlap quite well. In this case, we had some deviations in the beginning, but most of the time they overlap fully. So this furnace then allows us to do experimental testing, small scale, to develop our products, test out new applications in a quick and easy and relatively inexpensive way. One of the main drawbacks when we're doing external testing is the time. From idea, planning, shipping, traveling, getting a test report, it can take anything from 2 to 3 months. In this scenario, we have a request. We had one 2 days ago. We're planning a test later today, and we'll be able to give the customer some feedback on the performance by the weekend. So should be good.
Yeah.
It allows us to quickly figure out what works, what doesn't, test new materials, new integrations, and of course new products.
Yeah, talking about that, what kind of weakness and failure modes can we uncover by doing pre-testing like this?
So this is predominantly looking at two failure modes. For us, it's integrity and insulation. Integrity is kind of a catastrophic failure, where you see the flames coming on the outside of the test specimen, while insulation is all about temperature. So we have a slot for 12 temperature measurements here, and we place them then on the non-exposed surface of the test subject, and if they pass a certain level, we fail. One of the things that we struggle with furnaces like this is sudden flame impingement, sudden flame exposure. Basically what you showed us with your little cart.
Yep.
We don't have the same instant heat. I mean, a flame is what, 1,000, 1,500 degrees Celsius, while this one ramps up slowly to around 1,000 degrees Celsius over the course of minutes to an hour. So if we want to see how a product behaves when it's exposed to a flame, we need to look elsewhere. This isn't the right method for testing that.
And where do you look then?
We look to the States, or ASTM,
Yeah.
which is a global but predominantly American test society, or standardization society, I should say. And they have a method called ASTM E2912, which is ideal for this type of testing, and it's quoted in ASTM E2886, which is again a requirement for wild urban interface areas.
Right.
So the test has a lot of use, and it's important for wild urban interface, wildfire scenarios, but it's also a normative standard. It's been developed by peers, and it's following a voting process. So it's internationally recognized.
So the main differences between those two test standards, we're talking about this now, product testing and the ASTM, what would you say would be the key differences?
The key difference is that the ASTM has a flame impingement, a sudden flame impingement. So the exposure is really high from second one, while this ramps up more slowly. So this is how we test for fire resistance in a European context, like EI30, EI60. It's all based on this type of exposure. But for a wall, it's completely sealed off.
Yeah.
You don't expect flames to pass through it from second one, but for it to close in second 2, 3, 4. But for ventilating products, the need to close creates a possible vulnerability, a weakness. And it's hard to find that weakness and discern it in a test like this. But when we do the ASTM test, it becomes really clear that even though you have two products with the same performance in a furnace, they behave completely differently when exposed to the ASTM.
Right. And one of our products is, of course, the cavity barrier, which we have tested to European test standards.
Yep.
Is it possible to use that test standard to say something about flame?
You can say something about flame. In the latest version of the standard, there is a provision for testing to flame. But then again, you have the same heat exposure, the same relatively slow buildup, and no actual flames. So the flame rating you can obtain is really based on temperature and integrity in the European setting.
Right.
Yeah.
Yeah, cool. Okay, I think now everybody is ready to see some testing. So I think we will move outside and we will demonstrate the ASTM E2912, and we'll let we go outside and you can show us the application there.
Yep.
So Ole, here we have the ASTM E2912. It looks like a big table.
It's quite big,
Yeah.
but at the same time, it's manageable.
Yeah.
You can build it for any medium to large fire lab and tuck it away in a corner when you're not using it. We should disclose at this point that what we're doing here, obviously, is by far not an accredited test in any way. It's a demonstration. But the table is built to spec, the burner is built to spec,
Yeah.
the fire source is approximately built to spec. There are some discussions about what it should be, but our target is to have a flame that is approximately 1 meter high above the table before we kick it off.
Yeah.
But we're also outside,
Yeah.
and it's cold. I can sign any papers to verify
Yeah.
it's really cold.
Yeah.
And you're
Today was-
supposed to do this indoors with an ambient temperature that you can control,
Yeah.
like 15 to 20 degrees Celsius.
Right, yeah.
That would be amazing if we had it out here now.
Yeah.
So yeah, hopefully it will be a useful demonstration. And the thing we're burning is, of course, our Firebreather Cavity Barrier compared to a very much conventional intumescent strip.
Yep.
If we put these in the furnace, we would expect to see roughly the same performance over 30 to 60 minutes, roughly. There will be some differences, but they should be able to obtain the same classifications in a furnace setup.
Yep.
A little bit depending on placement of thermocouples and so on. But we hope that they will perform vastly different now that we do the flame impingement test.
If we could do some prediction here, that's always fun to do before a test. What do you think we will see?
I think we will see smoke, and I believe that on the conventional solution side of the table, you'll see a lot of flames and a little bit of a black snow, because we expect that the intumescent will disintegrate and be blown away to some extent during the fire.
Yep.
Can
Okay, like Ole said, it's quite cold today, so I think we'll just go ahead and start the test so we make sure that none of the technical equipment fails. So go ahead, Ole.
Light,
Yep,
there we go.
let's go. Here we go. So Ole, can you explain to us what we are seeing here? Let's start with this side. It's no,
we're seeing
no flames.
We're seeing the fire breather stop the flames from passing. There is a bit of heat coming through.
Yeah. What about the other side?
But there are no flames. If we go to the other side,
look at that.
It's a different story. Wow. So we can tell that the intumescent is starting to close, but it's not successfully closing until there's quite a few minutes have passed. And inside of the cavity, yeah, it's being broken apart by the flames. Yep. So even though it closes, it can sometimes be disintegrated and fail.
Yeah, because this is a known problem we see when we do a lot of this testing, is we see that the intumescent actually blows away or falls down.
Yep. So after a few minutes, the intumescent seal has closed for both products, but at this point, combustible materials in the cavity could already have led to fire propagation happening and bypassing of the barrier.
Okay, now we see that both are closed. So I think we end the test there.
Yep.
Because this was the whole point of the test, was showing the flame arrest, right?
That was the purpose.
Yes, okay. So while Ole and Frank here is dealing with the test, I think we will move on to the system test after we've shown how it looks. The application here I have shown you, it's the same application more or less like we did on the ASTM E2912. It was intumescent on this side, and it was which would be a conventional way to fire safety cavity, and on this side we have the fire breather. And also we made some plastic windows to show what would happen inside of the cavity. I will light it up, but first I will just put down my papers. Talking about predictions, I think I will make one now. It's just fun to do it to see if I was right or not. I think on this side, we will definitely see a lot of smoke. Probably the windshield would start to melt quite quickly. And hopefully after a while, we even will see that the plastic will melt. On the other side, I think it will be intact. I think it would. Okay, let's do it. See. Do it from the other side. It's a little colder weather, it's a little windy, so I think I need to do it again here. See? Okay, there we go. I think it will start to burn now. Okay, there we go. A little slow start today. It's because of the weather, it's quite cold. Okay, now we see it right away. You see it definitely, it's a higher temperature on this side where we have the conventional intumescent, while on this side it looks still intact. And Ole, can you join us for a couple of questions?
Of course.
Why do we need to do a system test?
Because furnace testing is based on room fires. And our products, especially the cavity barrier, is never mounted inside a room. Yeah. It's behind the cladding on the facade. And when it burns like this. Right. Which is a different exposure, different behavior than the furnace testing. So this is essentially a mock-up of a large-scale test in a very small format.
Yep.
But there you have the same. You have a N-heptane or propane or wood crib that is
look
set
at
on
that.
fire.
Yeah. What we're seeing here is called the chimney effect, right?
That is the chimney effect.
Yep.
It pulls the fire with the hot air and gases as it moves up the cavity, which can lead to ignition of combustible materials and flame impingement on cavity barriers, windows, details, what have you. And this is really one of the reasons why facade fires can spread tremendously quickly if there aren't proper cavity barriers installed.
And just to make it clear, what we are doing here and simulating on this side, it is very conventional way to fire safety a cavity, right?
Yeah, intumescent strips with an air gap in front of it.
Yep.
That's what you expect to find in 95% of buildings in Europe.
Yeah.
Some have even worse solutions, but this is like the industry standard.
Yeah.
And I'm not sure if I would be comfortable if that was my house.
No, I would agree. Yeah.
Vänta och se.
So what we are out talking about this, we are saying that instant flame arrest is critical, right? And this just shows that it is critical because the chimney effect will be effective right away.
Absolutely.
Yeah.
And when it comes to products like this and European standards, it is still early days. So I would say ask the right questions, ask for the right documentation, and if there's any ever doubts, then full-scale testing is the best way of fully knowing how your system will perform.
Yeah. Okay, Frank and Ole, whenever you are happy with the test, I think we can end it. And we'll give it a couple of minutes just to cool down, and then they will open up the wood, and we'll have a look inside of the cavity. So here we see the results, and it looks like my prediction came true. On this side, where we have the Firebreather, is more or less intact. Everything, even the windshield hasn't melted. And we see on the other side, where we have the conventional way, we see that the intumescent now fallen down and it still burns. So imagine in a large-scale building this happening, that would be very critical. Okay, I think that ends our today's webinar. Ole, thank you for joining us.
My pleasure.
On this webinar. And if you have questions, either from me or our technical department here at Flammer Norway, do not hesitate to contact us. You will find information in the description. And hopefully you enjoyed the webinar. Thank you. Let's go inside. It's cold.
It is cold.
Bye.